Lesson 6-1B, Properties of Exponents. So let's review what we did last time. What is an exponent? An exponent has a base to a power, and you can alternatively write it out using the expanded form. A radical has a base inside of the radical of the root, with the root that we're taking called the index. All right, so these are related because we can switch between the two. Nth roots of a to the m is the same as a to the m over n, where we have an exponent, which is a fraction, that's called a rational exponent. We can convert between the two, and each of these have their applications. We typically use these rational exponents to do operations with. Right, so we can do operations, adding, subtracting, multiplying, and we use this to simplify. So converting between the two has its strengths. We can do operations with this, and we can simplify with this. Properties of exponent vocab. So we have a product, and that is a multiplication of two numbers or variables. We have a quotient, which is the division of two numbers or variables. And we have power, raising a number or variable to some exponent. The first property of exponents is called the product of powers, and that is if I have a base of a to some m exponent times a to some n exponent, and that m and n are going to be added together like this. An example of this is if I have a to the fifth times a squared, then I'm just going to have a to the 5 plus 2, which is a to the 7th. But if you want to see it this way, I have 5 different a's, so I can expand all of these together. That makes 5 times 2, 1, 2. Then in total, I have 7 a's. The second property of exponents is called the quotient of powers, and that is if we take a to the m and divide it by a to the n, and it's the same as having a to the m minus n, where a cannot equal 0. And an example of this is a to the fifth over a squared is the same as a to the fifth minus 2, and that's going to be equal to a to the third. Now an expansion of this looks like this. So a times a times a times a times a. I have 5a a to the fifth on top, and then a squared at the bottom. And I can cancel some of these from top and bottom, leaving me with just a to the cubed. So this is another way of looking at it. The third property of exponents is called the power of a product. And that is if we have a term inside of parentheses raised to an exponent of n. And in this case, we're going to distribute the exponent to all terms or all numbers and variables inside. And we get a to the n, b to the n. A and b can represent numbers or variables. So this example, let's distribute that exponent to all of these. We're going to get 4 cubed x cubed y cubed. And we can further simplify if we multiply this out. 4 times 4 times 4. And this is equal to 64 x cubed y cubed. The fourth property of exponents is called power of a quotient, and that is if we have numbers or variables being divided by numbers or variables, and if we raise that to the n power, then we can distribute the n to every single number and variable on the division. The only exception is if b cannot equal 0. So let's distribute this 3 to all these numbers and variables. And then we have 4 cubed x cubed over y cubed, and we can simplify this for cubed again. 4 times 4 is 16, times 4 is 64. X cubed, y cubed. The last property of exponents is called the power of a power property. And that is if we have some numbers or variables inside being raised to some m power, in parentheses, raised to some n power. We're going to take all the variables m and n and multiply them with one another, like this. So an example of this is if we have a cubed in parentheses to the fourth power. This is the same as having a to the third times 4, which is going to be a to the 12. Here is a more simplified table that lists out all the properties. So you can pause the video here and copy all of these in one nice table. Exponents to the power of 0. So what happens if we have a variable or a number to the 0th power? It's always going to be equal to 1. And we can do a small proof involving the quotient of powers. So if we take a to the 5th minus a to the 5th, that's going to give us a to the 0, which in reality, this is an expansion of a times a times a times a times a at the top over a times a times a times a times a at the bottom. And all these a's are going to end up canceling out, leaving us with 1 in the numerator and 1 as the denominator. So 1 over 1 is the same as 1. And this applies to all the numbers and all variables. Negative exponents. So if you have a base, whether it's a number or a variable raised to a negative exponent, we don't want any negative exponents, and we can turn the exponents positive by bringing them down to a fraction. So a to the negative n is equal to 1 over a to the positive n. And the same thing, if we had 1 over a to the negative n, we can make this negative n positive by rewriting this, and instead of a fraction, bringing it up to a to the n. Some examples of this include this first one, where you can have 3 squared over this x to the third. And as you can see, we brought this under a division line. And then just to finish this problem, we can take 3 and square it. That becomes 9 over x cubed. All right, what happens if you have negative exponents here and in the bottom? Well, we can take this and bring it down, and we can take this one and bring it up. By bringing this one down and this one up, they're going to become positive exponents. So you can rewrite this as y x squared over 4 squared, and you can simplify the denominator as 4 times 4. 4 squared is equal to 16. All right, here we have some examples. So we have x times x cubed times x to the fourth. And using one of the properties, we can add the exponents because we're multiplying. So x to the first, right? I added a 1 here. So I can put all these together to have 1, x to the 1 plus 3 plus 4. And all these add up to x to the 8. Here I'm multiplying again. I'm multiplying numbers and variables. So I'll have to match them up. I can multiply the numbers together. So I have 2 times negative 3. I guess I could put them in parentheses here. Right? And then I can also multiply the x's together. And when we do multiply the x's together, we end up adding them. So x to the 2 plus x to the 3. And this y has a 1 associated with it. And when we multiply the y's together, we end up adding the exponents. So y to the 1 plus 4. All right, 2 times negative 3 becomes negative 6. X to the 2 plus 3 becomes x to the 5th. And y to the 1 plus 4 becomes y to the 5th. So this is my answer. All right, go ahead and try this problem on your own. You can pause the video. All right, so the same thing as the last video. Here we have numbers and variables. We can multiply the numbers together, and we can match the variables. So we have 3, 3, and negative 3. 3 times 3 times negative 3. And then we have x to the 3rd, x to the 4th, and x to the 2. So x to the 3. We're adding the exponents, plus 4 plus 2. All right. And multiplying these out here, we have 3 times 3. That becomes 9. And times negative 3. And multiplying these two, we get negative 27. Right, negative 27. And then adding the x's together, we have x to the 3 plus 4 plus 2. 3 plus 4 is 7, plus 2 is 9. So x to the 9th. And this is going to be my answer. Here are some more examples involving the property of the powers. So if we raise any exponent to the power, that's the same as multiplying the exponent. So we can essentially take this exponent and distribute to all the exponents here. All right? So x to the 2 raised to the 4th power is the same as x to the 2 times 4. And y to the 3rd raised to the 4th power is the same as y to the 3rd times 4. And we'll just have to take care of these multiplication. So x to the 2 times 4 is the same as x to the 8th. And y to the 3 times 4 is the same as y to the 12th. All right, same thing here. The only difference here is we have a number, and that number also has an exponent of 1. Okay, don't forget that. So when you're distributing and raising all these, you're distributing it to all the exponents. Okay, so 2 to the 1 times 2, x to the 2 times 2, and y to the 3 times 2. Multiplying these out, we have 2 to the 1 times 2 is 2 squared. X to the 2 times 2 is x to the 4th. And y to the 3 times 2 is y to the 6th. And we can multiply out the numbers. So 2 squared becomes 4. So 4x to the 4, y to the 6. Right, here's an example. You can pause the video and try this on your own. All right, so we have 2 to the 1st power, x to the 3rd, y to the 1st power, and z to the 2nd power, all being raised to the 3rd power. So let's distribute that exponent here, 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 and here. So you have 2 to the 1 times 3, x to the 3 times 3, y to the 1 times 3, and z to the 2 times 3. All right, 2 to the 1 times 3 is the same as 2 to the 3rd. X to the 3 times 3 is x to the 9th. Y to the 1 times 3 is y to the 3. and z to the 2 times 3 is z to the 6th power. And then I can multiply out 2 to the 3rd. If you remember, 2 to the 3rd is the same as multiplying 2 times 2 times 2 together. So 2 times 2 is 4, times 2 is equal to 8. So my final answer is going to become 8 x to the 9th, y to the 3rd, z to the 6th. All right, here are some more examples using the division property. So whenever we divide exponents together, we end up subtracting. We also have some exponents that are negative here. So essentially, you could do this in two methods, okay? I'll let you figure out the other method on your own, but on this one, I'm going to apply the division. So if we take x to the 3 and subtract x to the negative 2, because we're dividing, then we have x to the 3rd minus, okay, we're always subtracting because it's a division, but this negative does not take into account that this exponent is negative, so I'm going to have to add another negative here. So x to the 3 minus a negative 2 is the same as x to the 3 plus 2, okay? And so that ends up being x to the 3 plus 2 is x to the 5. It's same thing here, but we have no negative exponents in this case, so we have 5 to the 6th minus 5 to the 2, only the exponents, so like that. And when we subtract those two, we have 5 to the 4. And if you want to multiply this out, 5 to the 4 is the same as 625. All right, here's an example. Go ahead and try this on your own. You can pause the video. All right, taking these piece by piece, we can divide the numbers. We can subtract the exponents. Here, m to the 3rd minus m to the 1st for the m's. And then we can subtract the n's together. So n to the 5th minus n to the 4th. All right, the first thing I'm going to do is I'm going to pull out this negative. I know that my answer ends up being negative because I'm dividing a positive by a negative, so that ends up being a negative number. So I can pull that out. All right, I have 36 divided by 9. Okay, that's one operation. And then I have m to the 3 minus 1, because I'm dividing. And I have n to the 5 minus 4. All right, let's take care of this. Division 36 over 9 becomes 4. And I still have that negative right here. M to the 3 minus 1 becomes m squared. And then n to the 5 minus 4 becomes n to the 1st, or you can just write it out with n with no variable, okay? The default is a variable of 1. And that would be my answer.